I'm back again with a quick video. This one was on request from a YouTube viewer. The request was just a simple sketch that connects an encoder to Xplane through XPLPro. The one I've set up here, I have a rotary encoder hooked up to, I had an Uno around, so I did it on that. It's not hooked to interrupt pins. When I turn this, you can see that the heading on the HSI there follows it. I'm going to write some things that accelerate the movements here, because it can be a little cumbersome to get this to the heading that you want without any kind of acceleration code. But this is just a simple example for you. I'll bring up the code so you can see what we have. I've called this example XPLPro single encoder. I'm going to supply this with the XPLPro library package. It'll be in the examples folder next time you update. So XPLPro single encoder. I am using the encoder library that's available in the library manager. This is the one that I use, the encoder by Paul. I'm not going to attempt to pronounce that name, but this is the one that you're going to want to use. It's included here. I'm defining 2 pins on my Arduino Uno in this case. Encoder 0, pin A and B I have set for pins 8 and 9. You could use whatever pins that you like. It's encouraged to use pins that have interrupt capability for better performance, but I'm actually running 8 encoders on a Mega with my 737 MCP build, and that's working pretty well without any interrupt pins. I plan to add some capability later on if we're going to be using a lot of encoders, but for now we're just going to do this simple exercise. Alright, I'm creating an instance of the encoder that's on the pins that I previously defined as 8 and 9. I've got an integer value here that just tracks whatever accumulated value we have from the encoder. I've got 2 handles for commands. These commands will be called when we turn the encoder in different directions, one's for up and one's for down. I'll show you where they're defined later. Nothing special in here. This is just normal XPLPro stuff. In the loop, I do have it run encoders check, and I don't put a delay before that. It needs to run pretty often to be able to catch the quick little pulses that happen with encoders. In this case, I'm not handling any inbound data, so we'll leave that. Here's where we register the commands that we want to use. I've chosen to use the heading up and down, as you saw how that worked in the video previously, or the handles that hold the commands so we know how to reference them later. Here's where we check the encoders. I left some of the code in here and commented it out. This came directly from my 737 MCP build, where I'm using multiple encoders. So you can use this as an example if you have more than one. I'm just using the one today. It reads. I chose to use the read and reset function for the encoder. So what that means is that if the value is, for instance, 3, it will send me that 3 and then reset it to 0, and then I'm accumulating the number myself here. You could also just read it and then reset it as you need to separately. I chose to do it this way for this example. When that accumulation becomes less than -3 or greater than 3, I see that as a 1d10 click on my quadrature encoder. If you have encoders that are giving you different numbers for each click, you can change these numbers as is appropriate. When it sees an accumulation of 4, either positive or negative, it triggers the appropriate command. You might have to reverse these if your encoder's wired up backwards for whatever reason. And that's really all there is to it. I hope this was helpful to you. Your likes and subscribes really do help our channel out and encourage me to make more videos. I'll see you in the next one. If you have requests for any particular sketch that I can help you out with and you think will help others, I'll make a video for that as well. See you next time.